We're off. Hey, Jetro, I'm adding you as a contributor. And we are starting. So, first of all, it's great if we can have a live discussion here. So don't feel afraid to ask questions during my presentation. It's like an opportunity for both sides to learn new things, to discuss ideas, and so on. So I'll try to address everything as I go. And yeah, I'll keep an eye on new joiners to make them contributors because something got messed up here. But yeah, I'm sharing my screen now, and we can move to the presentation. So, do you see my screen?
Yep.
Yeah.
Okay, great. Huh. Okay. So, what we're going to talk today, basically, I'm going to showcase my flow for AI-assisted development. And I'm going to basically show you the following methodology that I kind of invented. And it's not an invention. It's actually based on the work of many great people out there in the industry, but I kind of found value in it, so I want to show it with to others. And it's based on, let's say, 3 pillars that are relevant to the practice. The first one is test-driven development. It's been pioneered by Kent Beck like 30 years ago or something, and it's a way to have executable specs that guide the AI precisely. So it kind of, spec-driven development has become popular, but frankly, it's been something that's been in the industry for the past 20, 30 years since since people found out about writing behavior-driven specifications and so on. So there's nothing new under the sun. I'll show you how I use executable specs to build in determinism inside the AI. Then we have working in small steps, which is crucial because usually when you share big ideas to the AI, it goes into rabbit holes, it starts making mistakes, and small errors compound and becomes big hallucinations. So working in small steps is the other really important thing we're going to do. And lastly, we are going to work within a modular architecture. I'm going to use hexagonal architecture, which is again something pioneered by Alistair Coburn, again a couple of decades ago. But all in all, by combining these practices, which are independent of agentic framework, of the IDE use, the LLM use, and they're actually something that lets people write code fast without AI. By using them, we are going to also speed up our AI process to implement stuff. And another thing is that now I'm going to dive a bit into each pillar because I'm not sure everyone here knows what these things are about. So first of all, I'm going to start with test-driven development. So as I told you, it's a way to anchor AI's unpredictability deterministically. So basically, we write something that the AI can execute, and based on its output, the AI then can decide whether it has done a good job, it has done what I've expected it from it, or it has done something bad, and then it gets into a self-correction loop that it executes until it successfully makes all the tests pass. And we are going to do the so-called double loop TDD, or where we first write a high-level acceptance test that fails, and then we're going to implement the details through unit tests. And then once everything is done, we move on to the next slice of work. Then we have working in small steps. As I told you, the chance of hallucinations increases with context size. Small errors accumulate and compound. So when we work in small steps, then we make sure to prevent the compounding of small errors, because we can correct things as soon as we see something that's unusual. And we receive really quick feedback on whether what we do works or not. And by small steps, I mean like things that you can see the result of in 5-10 minutes at most. And then we have a modular architecture, and that's becoming the scope of let's say an AI native engineer. So the goal is no longer to review the code and output that the AI provides. We have tests for that, and we rely on them. And we rely on the notion that once we have tests that pass, then it means that the AI has done what we want it to do. Instead, we care about what we start to care about is the overall architecture and design. So and guide the AI on this higher level of work. And lastly, of course, we are going to rely on like some other more, let's say, AI concepts, spec-driven development, of course, but we are going to do it not via tools like SpecKit or Teso or Kiro, but we're going to do it through executable tests in the form of like Cypress specifications. And we're going to look at what ground truths enable what we do. And for the newcomers, I'll say again, please feel free to raise your hand whenever you have a question. I really want this to be a discussion and a place where we can learn together and see and explore topics. If you're shy, feel free to just write your questions and topics in the comments. If you're not shy, just raise your hand, unmute, and let's discuss. I'll try to keep everything like in the span of an hour, but we might go a bit out of this time frame. So yeah, now it's the time for a demo, and I'm going to switch to WebStorm. I guess you see it. And this will be the core of the presentation. First of all, how is the font size? Do you see like that? Is it okay like that? Or I should increase it? Okay, I assume it's good enough. And let's see in the source, I'll increase it as well, maybe to 15 points, so all of you can see. And yeah, so what we have here is a really simple application that we want to build. We want to build a really ugly, simple personal finance tracker. It's just for demo purposes, and it will let you input like expenses, incomes, and each expense would be characterized by name, amount, category, and type, and we'll have totals. And we'll build it step by step in like really small slices of works, really small steps, so I can show you how I guide the AI to do this. And I'm saying again, this is nothing that I've invented in particular. It's something I've seen great people like Kent Beck do, Paul Hammond, if you know him, and other folks out there who are really pushing this field forward. And before I dive into it, I'll first start with the ground rules because they are really important to what we do. And again, the ground rules are from Paul Hammond. I just want to make adjust the font as I go. Again, they are from Paul Hammond. He uses the same ground rules and he has them publicly available in his GitHub.files repo. But basically, they're instructing Quad to do a couple of important things. The first one is test-driven development. I think this is the cornerstone of the practice. So if you have to take one thing from this webinar, it's do test-driven development, use tests as executable specs to ground the AI and make sure it does what you want it to do. And I won't dive deep here, but basically the ground rules show what does it mean to do test-driven development, and they also expanded on it through separate docs references. So basically, if your QuadMD becomes too big, then you can reference different files and use them. So here we have the testing doc that describes what we want in detail with examples and so on, because the current LLMs aren't trained on code bases that have good tests. So we have to make sure we give good examples. And we have the same for TypeScript. What does it mean to write high quality TypeScript code? And we have more details in the TypeScript doc. We have the same for code style in general, development workflow to follow the red-green refactor loop, some example patterns that are covering everything else, the workflow with Quad. So basically, when to do TDD, when to do refactoring, when to update QuadMD with new insights, and so on. And we have some resources and references. And this repository is publicly available, so you can just check it out and dive deeper into the instructions. Personally, I've learned a few things that have made me a better developer from these instructions. And also we have a couple of sub-agents that will help us work better. One of them is the TDD Guardian, which ensures that we follow the test-driven development steps properly. We have the TS Enforcer, which verifies whether TypeScript rules have been followed. We have the Refactor Scanner, which scans for refactoring opportunities. We have the Learning Agent that updates our ground rules based on new incoming knowledge, and so on and so forth. And maybe the other important one is the Work in Progress Guardian that keeps a document that describes where is the current implementation going. So we can, if we stop in the middle of our work, we can easily resume afterwards. So yeah, now let's focus on the actual work. I'll start Quad here. I'm using Quad Code extensively. And as I told you from the presentation, we want to do an outside-in TDD. So I'll first start with writing a failing acceptance test. And the way I usually do it is I have a, let's say, a high-level spec, and then ask the AI to translate this high-level spec high-level textual spec into a Gherkin file, and then generate the tests from the Gherkin file. I find that in this way, I have the best tests in terms of like them being behavior oriented and not focused on implementation details. But of course, you can experiment with skipping the gherkin phase. So I'll start with, I want to implement a personal finance tracker. First, it should just support adding a new expense by name and amount, nothing else. And this is about the small steps that I've been talking. I choose the smallest slice of work. Probably there might be even a smaller slice that's meaningful, but I default to that. I choose a small slice of work that after we implement it, we'll have something that does something meaningful, like a piece of the product that's useful to people. And I'll tell it at first, just based on that, just implement a working spec with the main requirements. And I'll list the main requirements here. So first, the user should be able to add multiple expenses and see them in a table. So we're talking about acceptance level tests. So I want to write an acceptance level test that verifies the main happy path of the behavior, and then I'll try this out with some unit tests to make sure it works properly. And the other test should be, and I'll be vague here for now, the input should be validated. Of course, if you you have the option here to be more specific, but I found out that especially when we use Gherkin, the AI can reach pretty good conclusion about what is important to be validated and not. And I always start with plan mode, let it think for a bit to come at the best requirement, and that's usually quite fast. So it's generated several scenarios: a single expense, multiple expenses, empty expense name, and invalid or zero amount. And here I'll just tell it to skip the first scenario because I think it's trivial. We'll go through it in a unit test. There's no need for it. And usually what we can also do is think harder about edge cases and other important scenarios. But again, I'll skip that for now. And I'll tell it, leave out the first scenario. Just have a simpler spec. And then I'll tell you, yes, let's write this in the rec. And then we kind of build through these Gherkin files, we also kind of build the specs that we can use later to have some initial scaffolding for the system. So this is the spec. We are dating it. Now it should be ready. Yeah, we have it, and now we can ask it, now generate a Cypress component level test based on this spec. The test should be on the level of UpTSX. I'm asking it explicitly to use UpTSX because otherwise it will just write a test for the new expense component, and then I'll have to tell it to integrate the expense component inside UpTSX, and we won't have a test for the integration with between UpTSX and the expense component, so I prefer to make this on a bit higher level than the actual expense component. And this will also let us do a proper refactoring afterwards. And I start this again through the plan mode. And it figured out the tests, and I'll tell it to auto accept the edits for now, and then I'll just review the tests. Again, the most important part of my job is becoming not to care about the implementation, but to care about the tests and the high level architecture. So that's what I'm only going to review. And now it will figure it out. It created it inside the source directory. It will verify it, and yeah, probably it will take it some time. So if you have some questions, now it's a good time to ask, or if you have some things to say in general. Yeah, hey Stuart. You can unmute yourself or just write in the chat. You can't. Maybe you should. No, I can't. Maybe you should try to log in again. Or just write in the chat. There's some issues, probably because. Okay, so until Stuart unmutes or writes his question, we can see the what Quad has created for us. So here we have the component level test, and we see raise the font a bit. We have basically the things that were specified in the Gherkin file. We have a test that adds multiple expenses. That's coffee, that's 550, that's lunch, that's 12, and then it verifies whether they exist, and then it has the validation errors. And it also verified whether the tests are failing by running the Cypress tests. And then that's our baseline here. I see some errors. So I also ask it, please verify that the newly created specs pass all type checks, linters, etc., and only fail because the functionality hasn't been implemented. And that's really important because usually it will find this out during the last step, and it will start doing multiple things at once, like making sure the tests pass and making sure that all the linters and TypeScript errors are fixed, which from my experience, it might lead to errors. And Stuart is asking, regarding the grounding rules, do you think the benefits of the TS enforcer outweigh the downsides of adding to the context window usage when TS rules can be enforced by the linter and compiler? So the TS enforcer is, I don't think it's only about things that can be enforced through TS rules. Because they also look into other stuff as far as I've looked into them. It verifies first that the actual TS rules are properly set up. It has some things that can be enforced automatically. but it also has, for example, it validates whether all new domain objects use ZOT to define the schema, and so on. So probably some of these stuff can be, and it also like verifies immutability, and so on. Probably some things that can't be automated. So I think both should be done here, like having automated checks by the linter and compiler, and then relying on TS enforcer for stuff that can't be automated as easily. So now, as we can see, it's fixing the Cypress issues. It will, yeah, it will go through them. And after it fixes them, then we can continue with implementing just the first step. We won't care about validation yet. We'll just make sure the first happy path tests pass, and that the component that we've generated is in its proper place. And probably while it does it, I can start another agent. And I don't need to use Git work trees. So now we have this test, but before I tell Quad to just implement the component, I have to follow good design here and separate the business logic from the presentation logic. The business logic here is pretty simple. We have a list of expenses that we can add to or remove from it, and we have some general expense structure. So implement the domain object inside source features expenses domain that tracks expenses by name and amount. This domain object should only support adding a new expense. It should satisfy the following requirements. When there are no expenses, the list should be empty. When there are multiple expenses, they should be present in the list. And let's be more specific, when there's a single expense, the list should contain one expense. And probably there are more things to consider here, but just for that part, I want to keep it simple. And now it should, okay, we have the tests, they fail for the proper reason. I'll tell it to please commit your work to do a commit, and meanwhile the other agent is thinking in quotes on how to make the tests, the unit tests pass, or to implement the domain object itself. And here it has created the commit. It will add the relevant files, and yeah, and commit them. Meanwhile, of course, now the other agent is trying to understand where it's at, because it doesn't have any context yet. So it will take it a while to export stuff. And this is done. And for now, I can't really spawn a second agent because I'm still working on the addition phase. and I don't want this webinar to become like too hard to follow. So yeah, it has understood what to do. It will define a schema for what's an expense and what's an expense list. It will create a test for the domain object. Then it will implement the domain object. It will refactor it, and that's all. And first I'll manually approve edits because I want to review the tests before I let it run wild. As I told you, that's the most important thing here. I'll just accept the schemas as they are, and then we have the tests themselves. So this will help me verify whether the contract looks okay. So we have an expense list, and at first it's empty, and we use and then we have it's functional, and that's based on the ground rules that were set up. So after we create an expense list, then we add an expense to it, we verify that the list contains it, and then we have a list with multiple expenses. And we verify that once we add all of them, we have all the expenses in the list. We allow this and then allow all edits. So now I'm confident in the tests. I let it run wild and do what it wants to do. I don't care about everything after the tests. To try to figure out what to run. Of course, this code base can be improved a bit. Maybe I can add to the code rules, like does it do type checks, how does it do linting and tests, so it doesn't have to figure it out by itself. But yeah, that's like it's definitely something that I've definitely found out in my work is that if you want to be fast, you have to make sure that quote understands your context and it adapts to your code base, to your commands, practices. Otherwise, it will waste tokens and cycles in figuring stuff out. And yeah, we have the domain object, and now I can ask the first agent, like, now make the first acceptance test pass by implementing the React component and using the domain object. Business watch. And this will let us, and I'll I'll just accept all edits. And from a hexagonal architecture point of view, the expenses model is the entity. The entities contain all of our business logic and separate it from everything that's, let's say, an implementation detail. Probably quite important implementation detail, but we want to make the business logic independent and independently testable from everything that's outside. So our React component in that case is an implementation detail. It's the presentation layer of our application. So it's sitting here and it's taking care of this acceptance level integration test that makes sure that it properly works together with the entity, in that case, the expenses entity. Okay, and now it's going to implement it. Meanwhile, just out of curiosity, we can have a look at the expense object. It's, as I told you, really simple, but that's also a simple app. Like here we'll support removing an expense, and probably that's all. But in like more complicated scenarios, you can have some more complicated logic here, and that's why it's important to isolate it and test it independently. Like you can have, yeah, no, I mean, probably all of you as engineers can think of many examples of complicated business logic um, that should be separate from everything else. And now it has implemented it. It has put everything inside app.tsx, and again, and that's all. And probably we should ask it to do some refactoring. But again, as long as the acceptance level test passes, I don't care about the exact implementation. And another thing that I just noticed is that it hasn't committed this. So I'll ask the first agent, please commit your changes. Because after each small step that we do, it's really important to make sure it's committed, pushed. So if something goes bad, you can then easily just revert and start over. And here's the feature, the domain. And if I run git status, I can see that what's not committed is the new changes that we have created through the other agent. And it's interesting that we have some changes to package.json. It's installed Zod. We'll commit that as well. Let's commit. Of course, it wanted to commit more stuff than I expected. Just package JSON, nothing else. And that's why you have to work in small steps and verify some of the stuff, because otherwise the agent can do wild things. And package walk. Meanwhile, it's having some difficulty in making the test pass. Probably it's some configuration issue. Why does... Yeah, it tries to mount just home. But I want to test things in integration, so I'll instruct it here to do things properly. Yes, we commit. Now it will take into account app.tsx. Okay. Meanwhile, if you have any questions, feel free to ask in the chat, or I hope you can unmute yourself and just ask in the uh, in the in Google Meet.
Maybe
There
I'll
is a
go ahead.
question already.
Oh, sorry.
Uh, Chat
There is
or
a question. There is a question in the chat already.
from Stuart? I answered it a while ago. If that's,
Oh,
I don't see any other questions.
I was going to ask a question.
Yeah, go on.
So yeah, I actually don't know TypeScript or much about web development.
Mm-hmm.
Yeah, I'm more into C++ and Python. So
Mm-hmm.
for me right now, it's a little bit difficult to judge what is the ratio of the effort in preparing all of those tests and all of this extra work in comparison to how much we're actually getting out of it.
Mm-hmm.
I mean, the smaller the steps that we work in, the more kind of overhead we have in working with the AI as opposed to actually going in and doing it by hand ourselves, right?
On the one hand, you can look at it like that. Um, in my experience, it helps by not having to care about these details. I
Mm-hmm,
can think about other things, and I can rely on the tests and the AI doing the boring stuff.
mm-hmm,
While I plan ahead, I probably launch another agent and do another part of the application.
mm-hmm.
And I actually find it way easier to have this workflow in in like in the back end than in the front end. So yeah, does that answer your question?
So you are working on a higher level in
Yeah,
this way. You're staying away from the low level details.
yeah, that's my goal. That's my
Yeah.
goal, and I haven't found how to do it in bigger steps. Like people say they instruct agents and then let them do their job, and then they just review thousands of lines of code. That might be valuable. That might
Mm-hmm.
work for them, but I just find it really inefficient to review thousands of lines of code, and then when I make another change, not to have any tests to protect me from the next change.
Okay. Yeah, that's a good argument.
Okay, thanks. Lucas?
Yeah, I was wondering if you have worked in this way in larger code bases and what was the result so far? Because in my current situation, we are struggling a little bit with the AI because our current setup is not ideal, to be fair. So we don't have many tests yet. And even our code is quite uh, spaghetti, I would say.
Mm-hmm.
And we figure out that we're having a lot of problems sometimes in the code generation because it is trying to rely on our existing context. Have you passed for anything similar?
Yeah, at a few places. Basically, I've noticed that in, let's say, legacy code or companies that probably haven't had the time to or knowledge to follow good practices, there's the real challenge in integrating AI to help you because, like here, it's straightforward. I have a greenfield project. I dictate everything. I have all the time in the world. Um, from my experience, the real value is like in the process of making the necessary changes and finding the necessary, let's say, um, seams where you can start um, making things useful, like making things work with AI, if I can say. So, for example, if you want to add a new feature, and um, it's really hard to do it because, for example, the business logic is tangled with the database or with the presentation layer. Then that's a really good hint about, let's say, a core issue of your system. So actually, the usage of AI, the proper use of AI, is showing you where you have to fix some technical debt and where you can improve the system. So you can, for example, extract the business logic, put it into under a proper test harness, and then iterate with the AI on it. And on the other hand, like have an acceptance level test that makes sure things work in integration. Like it's not as simple to do it as I described, because like some legacy systems are pretty tangled and spaghetti. But from my experience, this is a good thing you can explore and try to solve it. And usually what I do is I don't try to fix the whole system. I try to fix the system just enough so it can support me in adding the next feature in the proper way I want to do it. And sometimes that's possible, sometimes it's not. It's also a matter of skill. Like the more you do it, the better you become, the faster you become, and then the deadlines you have are not so much trouble for you to actually make the change in a good way. Does that answer your question?
Yeah, it does. It makes sense for me as well. We are working now in a greenfield project, and the result has been fantastic.
Mhm.
But indeed, when the code is legacy, then it's harder. And I think refactoring smaller steps is probably the best way indeed. Thank you.
You're welcome. So yeah, it got stuck. I know why it got stuck in this thing. I will just kill it actually and restart it, and I will say make up CITSX pass. And then after I do this, we can wrap up. And yeah, meanwhile, if you have any other questions, any other experiences from the wild, especially if you disagree with this approach or have seen it not work or think it doesn't work, or you have a better approach that you've seen work quite well out there, I'd be really curious to discuss it with you right now. So I'm challenging you to criticize. Okay, so I'll run this so we can see what it has done. So here we have our ugly finance tracker. It can add expenses, list them in a table, and so on. And probably the last thing we can make it do, and of course it hasn't implemented the validation part. Oh, it started to implement the validation. Okay. I'll just stop it for now. And I'll just commit what we have. Please commit what we have now. And then as a final thing, I just want to tell it, make this beautiful and see what happens. And I'll actually do it with the other agent. Make up TSX beautiful. Yeah, yes, Stuart?
Yeah, your last prompt brings up a question. How has your experience been in doing front-end development with AI? I haven't been able to get very good results in terms of styling things correctly, etc. I'm wondering if you have.
Yeah, that's a good question, and I'll be frank, I also haven't found it quite useful with like with styling and design. And here, when I told it to make the component beautiful, it thought it should refactor it, which is also good. But what I don't know if you know, but Google released anti-gravity yesterday, or it was a few days ago, and I think it's promising in terms of front-end work, because I saw here in the examples they shared, you can kind of uh, highlight a part of the UI and just say, well, this should look in another way. So in terms of demo, this looks quite promising, especially uh, for front end work. But I haven't tried it yet to see how good is it. And I see Lucas has the same issue. So yeah, but I think that's the next thing we should like figure out in our field. I found it out that in backend work it's way easier. Yes, Stuart?
Yeah, another question on architectural approaches.
Mhm.
Personally, I'm a fan of hexagonal architecture, but not everyone is.
Mhm.
And I'm wondering if in your research and experimentation, did you come across any other architectures that work well with this approach?
Well, probably that's why in the presentation I'm saying modular architecture. My guess is that as long as you have clear places in which to put things, you can have good value from using AI. But if everything is chaotic, then AI will deal with it just as a human does. It will be hard. So I guess in a hexagonal architecture it would be easiest, but I won't be like surprised if any modular architecture does things well enough.
Yeah, makes sense.
Okay. Nicola has joined at the last bit. So Nicola, if you have any questions, Nicola is doing a lot of QA things. So yeah. And let's see how good design it will generate. Meanwhile, if I'm also doing company workshops with this approach, so if anyone wants to talk about it and explore this with your team, just scan the link. This is the link to my LinkedIn. I'm happy to talk, and even if it's not about a workshop, just sharing knowledge together, let's do that. I think it will be beneficial, and I'll leave this on the side while we are waiting for the design to get better. Simeon, have had work with like navigating the AI to properly implement designs and front-end work?
Yeah, what works best for us for now is using the Figma Make artifacts
Mm-hmm.
and giving them as a context
Mm-hmm.
straight to the model.
Mm-hmm.
Well, it needs a lot of polishing afterwards, but basically it's a good starting point.
Mm-hmm. What is Figma Make?
Yeah, the Figma Make files, it's a pseudocode that the Figma AI produces. So you can handle all the product demo or prototype in Figma itself,
Mm-hmm.
and you get a working presentation, so to speak,
Mm-hmm.
but it's not ready for development. And you can export part of the code, give it as a context to the LLM.
Aha. So it's like, is it pseudocode or it's
It's pseudocode. Yeah, it's
Uh-huh.
pseudocode, but it's a working prototype. So you can easily use it to as a instead of a presentation to
Mhm.
validate, for instance, with some business teams or whatever.
Mhm.
And if you're happy with the design, because Figma, you can use the AI in Figma, and it's focused on the front end. So you can get a pretty good result inside Figma using their AI,
Mhm.
and after that, give the context to the coding LLM. In your case, Claude. Yeah.
Aha. So you iterate in Figma and then give this pseudo
Yep.
quote and let it translate to HTML and CSS basically, or React
Yep.
components.
Yeah. Yeah. This is okay. It's not perfect, but it's better than everything else we tried.
Yeah. Okay. Okay, that's good. I will definitely check it if I have the time. And does it require like designers to work on it?
No.
Uh-huh.
Unfortunately for the designers, no.
Okay.
It's
I'm asking.
your usual LLM, text-based prompting.
Mhm.
It follows some of the same setup concepts that you showed with Claude. You
Mhm.
have the markdown configuration file. You can give it guardrails. You can forward it to some of the design system components that you use.
Mhm.
So it's yeah, they've put a lot of effort in, and it shows.
Okay. I see. Yeah, that's good. Yeah, Chad here is a designer, so maybe he can also say a few things about Figma and cooperation between developers and designers in the like AI era. If he isn't too shy.
No, I'm not too shy, but I don't have experience exactly with that. I mean, with Figma Make, just because I think it's useful when you make some, explorations and stuff. But if you want to create something, like a high quality design, it's just not the tool.
Yeah, it misses features.
Yeah.
Okay.
But I'm happy as a designer that we have such tools, just because, it saves money. You're able to do a very cheap explorations, and also, this is a way for better designers to stand out and try to do a better job than AI, which is getting hard and hard each day.
Yeah. Okay, so this is the redesign we got. As we can see, and exactly on the topic we talked about, it did something okay-ish. I mean, for some reason, it's not full screen, and it uses, I think this is rupees, no? Indian rupees, yeah. It uses Indian rupees for some reason. But it has implemented the feature that we didn't want it to implement yet, which is another trait of AI systems that they usually, if you're not working in small steps and telling them to do something big, they can invent things that you didn't ask for. Like we can have Brett, it will do the sum here, but we definitely didn't ask for any currency, and we didn't ask for the totals yet. So this just amplifies the importance of working in small steps. So yeah, that's all from me. I'd be happy to chat further if you have like any ideas, insights about AI native development. And yeah, feel free to find me on LinkedIn. Let's talk. Or yeah, I hope you've enjoyed it. And I'd also appreciate any feedback you have on the presentation, which you can share on email, LinkedIn, whatever. So that's it. Thank you all. Bye.
Thank you.
Thank you.
Thank you.
Bye.